about approximation. Consider a function f such that d to r, where r is the real number and d is a subset of r. We have a function y is equal to f of x. As you can see in the graph, it goes from down to up. If we have increments, we have a small increment in x, that is in the function f is del x, and the corresponding y is del y. We need to obtain the slope. So we in the point P, that is x comma y. When we have an increment at Q, it becomes x plus del x comma y plus del y. In order to obtain the slope, we don't have a perfect triangle to obtain the slope. So we draw a tangent passing through the point P. So here the del y becomes even more smaller and becomes dy. And dx is equal to del x because the tangent doesn't affect anything in the x-axis. It doesn't affect the x-axis. So dx is equal to del x. When we see that the small change in y, that is y plus del y, is equal to f, that is the function y is equal to f of x will become f of x plus del x. Del y is equal to f. We need to obtain del y, the approximate change in y. So the increment in y. So we take the y the other hand to RHS and we make it as f of x plus del x minus y. So we have, from this y is equal to f of x. So we obtain that del y is equal to f of x minus f of x. When we differentiate x, it becomes dx, and when we differentiate y, we obtain dy by dx into del x. Here is the proof that del y is equal to f of x plus del x minus f of x. Now we are going to see about how to evaluate definite integral a to b square root of 1 minus x squared dx. So this is actually an experiment based question. See, we have a circle of a unit radius. Let's take it 0, 1. So when we have like this, the one quadrant of the circle is I have drawn here. When we divide these into segments, lines, so we obtain points P0, Q0, P1, Q1, P2, Q2, and so on to P10, Q10. So that will be denoted as y0 to y10. So we have I have taken some values from the unit circle 0 to 1. So I have taken a as 0 to b is equal to 1. So now actually when we see here, when we take the approximate values, 0.9 y0 is equal to 0.1 because we start from the origin. So, and I have got some values for y1, y2, y3 and so on to y10. y10 is equal to it is nearly, we can take a number which is nearly to 0, so we can neglect this. So here when we calculate the area of quadrant of the circle, as I have told you before, we have taken only one quadrant of the circle. It is equal to the sum of areas of the trapeziums. That is equal to half into 0.1 into y0 plus y1 plus y2 plus y3 and so on to y9 plus y10. So when we add this value, 0.1 is the width of the trapeziums. So when we add these values, we obtain some 0.99. We obtain a value like this: 1 into 0.1 into 0.774 when we add this value and divide it by 2. So we will get around 0.774 square units. So now we are going to verify it with the actual integration as we do in daily life. So that is integral 0 to 1. So I have taken 0 to 1. So I have integrated like this. Definite integral of 0 to 1 square root of 1 minus x square dx. We have the formula that x into root of 1 minus x square divided by 2 plus half sine inverse of x. Which with the formula I have derived this equation 0 to 1. So half into pi by 2. When we do this, when we substitute the values, we get 1 into 1 minus 1 square divided by 2 plus half into sine inverse of 1. When we this becomes 0, right? So we will have only half into sine inverse of 1. Sine inverse of 1 is equal to pi by 2. So half into 3.14 divided by 2 gives us an approximate value of 0.785 units, square units. So this is how we integrate with the limit of sum with the activity, and we can verify it by the actual integration as we do in daily lives. Now we are going to see about how to find absolute maximum and absolute minimum with the graph. So now here we take y is equal to f of x. The function f of x is equal to 4x square minus 9 into x square minus 1. It is between we take the definite interval, that is closed interval, minus 2 to plus 2. The values are being substituted from minus 2 to 2 and observed to be x, the values of x and f of x, and we record it in an order pair, x comma y is equal to f of x. So now here are some values that we have found, that is when x is equal to 0, f of x becomes 9. When x is equal to 0.5, it becomes 6. It becomes 6 plus or minus. When x is plus or minus 0.5, the f of x becomes 6. And when x becomes plus or minus 1.27, it becomes minus 1.56. When it is x is equal to plus or minus 2, the answer is 21. F of x becomes 21. So now we will plot the graph with the free curve, with the free hand. So x is equal to 0, it becomes 9. When x is equal to plus 2 or minus 2, it has 21. F of x is 21. So it will be here. It will be approximately here, and this side it will be here. And 0.5 plus or minus 0.5, it will be here, and we will take another value minus 3 by 2, and we have minus 1.56, 1.27 here, and 0.5 means it will be here. So we will plot the graph with the free hand. So it will go down by like this and reaches here and go up. Come down like this and go up. We have drawn a graph with a free hand. So here the maximum value obtained in the interval is the absolute maximum value. When absolute maximum, the value of absolute maximum is, here we have the highest number 21. So when f of x is 21 at x is equal to 2, the absolute maximum, the point of absolute maximum is at x is equal to 2. Same way, we'll have the opposite of absolute maximum is absolute minimum. That is, here in this area we have plus or minus 1.27 has the minimum value minus 1.56. The value of absolute minimum here is minus 1.56. The point of absolute minimum lies in the at x is equal to plus or minus 1.27. So this is how we find the absolute maximum and minimum with the help of a graph. Thank you.